Okay, good day everyone. Okay, good day everyone. This is the SWOT effects, and teaching you once again is Tommy SWOT. So today we'll be looking at what we call in chemistry, what we call chemical equilibrium. Chemical equilibrium. Chemical equilibrium. And talking about chemical equilibrium, we must first of all evaluate and know what the equilibrium there seems to be. And equilibrium is a state where is the state of a system, or can be defined as the state of a system where there is no observable change on the properties of that system with respect to time. Now, and under equilibrium, we have what we call types of equilibrium. For the equilibrium, we have types of equilibrium. We have two types of equilibrium. One, static or stationary equilibrium. Now, this is the type of equilibrium whereby the system is at a state of rest. It is stationary. I get an example of this kind of system is, or this kind of static equilibrium is let's say a balanced seesaw. A balanced seesaw. Balanced seesaw. But our main focus is not static equilibrium. Our main focus is chemical equilibrium. Then the second form of equilibrium is what we call the dynamic equilibrium. Dynamic equilibrium. Now, this dynamic equilibrium is an equilibrium whereby there is a change, meaning there is a forward and a backward reaction. You know, what I mean by change is that it can go forward and it can also go backward. But at the same time, this equilibrium is what we call a reversible form of equilibrium. A reversible. It is called a reversible form of equilibrium, or it is also known as an equilibrium which happens to have what we call reversible reactions. Reversible reactions. It means that in this kind of equilibrium, there is nothing like being stationary. There is movement. It goes forward and it goes backward. But for example, for this balance seesaw, it is just on one spot. Nothing is moving, nothing is moving, and nothing is coming or nothing is going like that. But for dynamic equilibrium, there is always a movement forward and a backward. There is always a movement forward and backward, which denotes this sign that is here, which is what we call a reversible reaction. Now, in a reversible reaction, we have forward reaction, and we have what we call backward reaction. Now, meaning that there is a change. It is going forward and it's also going backward. No, now, meaning there is a change. Now, this signifies change, right? This signifies change. This signifies change. And to explain this further, this signifies change. We have types of change. We have types of change. We can have what we call the physical change. We can have what we call the physical change, and we also have what we call the chemical. Change. Now, these two changes now are generally known to be the types of change that we can have in any form of reaction. So let me talk about what we call the physical change. The physical change is basically a change. Basically, it has a forward and backward reaction, but it's one of those changes that when you are separating using separating techniques, right? Using separating techniques, it's quite easy. It involves physical combination, and the separating techniques. The separating technique also require a physical form. a physical form. It also require a physical form. For example, let's say we have beans and let's say we have, for example, we have beans and groundnuts. Now this kind of example, now you mix it together, and by mixing, the kind of physical change that you can apply to this is that you can just handpick. Right? Now the state of these beans is still how they are. Their state does not change, and the way you unpick them also does not change. Like you unpick and you separate them separately, they still regain their form. Are you getting it now? But when it comes to chemical change now, this chemical change involves the separation using chemical means, or separating techniques that involves chemical means. For example, let's take a look at sodium chloride. A solution of sodium chloride. Now for solution of sodium chloride, after this is salt, this is, for example, this is what we are talking of, solution of sodium chloride. Let's say we are having salt plus water. Then for us to mix this salt plus water, right? That's okay. I'm trying to use a physical a technique that we can always remember of. Now this technique involves evaporation for us to get our salt and for us to get our water back. I getting what I'm trying to say now? So for us to get our salt and for us to get our water, this is, let's say, salt plus water. Salt plus water will give you a salt solution. I get my point. So that's the solution of sodium chloride. Now for us to get our salt separately and for us to get our water back separately, it means that we need to evaporate the water, which is the solution. Once we evaporate the water in the solution, we have the water being collected out in another form, and we have our salt being crystallized at the lower part of the container or the beaker. I get it now. So meaning that we're able to separate it using a chemical means. We use a chemical means. So that is talking about the chemical change. I get my point now. Physical change involves separation by physical means. Chemical change involves separation by chemical means. Are you getting it now? So this is what will now lead us to explaining a chemical equilibrium. Now the state whereby this salt and water with the salt solution are equivalent is what we call chemical equilibrium. Now chemical equilibrium is the state, or it is the state in a reversible chemical reaction. Reversible chemical reaction. It is a state in a reversible. Okay, let's have it now. Let's have it here. Now, chemical equilibrium is the state in a reversible, we need to state it, reversible chemical reaction, where the rate of the forward reaction equals the rate of the reversible or backward reaction. Now take note, resulting in no net change in the concentration of the reactants and products over time. Now, from the definition of equilibrium, I said earlier that equilibrium is the state of a system where there is no change, there is no observable change, right? There is no observable change with respect to time. But here now, in chemical equilibrium, what you should take note in chemical equilibrium is that it involves a state, one, and also it involves what we call, it is also a reversible chemical reaction. Because we are talking about chemical equilibrium, so it is a form of dynamic equilibrium. Are you getting it now? So as much as we have chemical equilibrium, we also have what we call physical equilibrium. Are you getting it now? So from this example of beans and groundnut, we can also, because it involves a physical change, right? Because it involves a physical change, we can also call it a physical equilibrium. So chemical equilibrium involves a chemical change, we can call it a chemical equilibrium. And also all these equilibrium, physical and chemical equilibrium, they are a form, or they have what we call reversible reactions. So they are what we call dynamic equilibrium. As long as they can move forward and as long as they can move forward from here, they can move forward and they can move backward, we call them a dynamic. Dynamic means movement. Do you understand now? So let's proceed. And in the definition, there is a rate, or where the rate of the forward reaction equals the rate of the backward reaction. Rate of forward reaction equals the rate of the backward reaction, or the reversible reaction. And taking note that there is no net change in the concentration of the reactant. Now, there is no net change in the concentration of the reactants and products over time. Now, this is what I want you to understand. In a reversible reaction, we make use of a sign of this symbol that goes like this and that goes like this. This indicates a reversible reaction. And when they are moving forward, this one going back here is a backward reaction, and this one going forward is a forward reaction. So backward reaction is talking about our reactants. Then forward reaction, this is forward reaction, this is backward reaction. Then forward reaction is talking about our products. Do you get it now? So that is what we need to understand first of all. Then don't forget, our main focus for this chemical equilibrium is our equilibrium constants. Right? So let's now talk about what we call the types of equilibrium. Types of chemical equilibrium specifically. So let's talk about types of chemical equilibrium.